Here are 5 labs I suggest doing with this gas lab program. There are other labs you can do, but these are the 5 basic relationships that you probably want your students to know. The first one would involve looking at the connection between the temperature of the gas and the speed of the average gas particle, in this case krypton. Okay, so to change the temperature, you simply change the environment that the piston is in. Since the piston is uninsulated, the gas inside will quickly reach the temperature of the outside environment. So you could have the students cycle through some different environments, recording temperature and average speed. Then you could have students look at the connection between mass and speed. And to change the mass, they change the sample. So it starts with krypton, and they can cycle through all the other noble gases. They can record the masses and the speeds of the particles. Okay, then students can take a look at the different gas laws. So for instance, with Boyle's law, we'd want to keep temperature constant. To keep temperature constant, we leave it uninsulated, and we make sure that the environment does not change. So then all students would have to do is record volume and pressure. Pressure they can get by accurately reading the pressure gauge, and the volume they'll get by realizing it's a 1 by 1 meter container where the width of the container changes. They get the width by going to the spot right at the edge of the moving piston and by measuring the width. So this would be approximately 90 centimeters for the width. They can change the size of the chamber by moving the piston using the arrows. And by moving it to a few different locations, students can discover Boyle's law. The next thing students might want to do is fix the piston in place. So instead of having a fixed temperature, we now have a fixed volume. We then change the temperature like we did before by changing the environment. And as we change the environment and the temperature, we would record the temperature and the pressure. We then would let the piston move again, and this time we want to keep the pressure constant. So as long as we don't manually push harder on the piston, we allow the piston to just find its natural volume based on temperature. We will have a constant pressure, and we can look at the connection between temperature and volume. When doing this, the person holding the piston in place will make sure that the pressure does not change. Okay, so as we change environments, we get new temperatures and new volumes, but constant pressures. So these are the 5 suggested experiments you can do with this program. Obviously, there are other data that you can collect and other experiments you can run. So you can look at how much work is done, how much heat escapes in different processes. You can investigate adiabatic processes by surrounding the piston in Owens pink so that no heat can escape. Okay, so hopefully your students can benefit from this program and discover at least the 3 gas laws and the connection between mass and temperature and speed.